From MCJ, I'm Cody Sims, and this is MCJ's Startup Series. Today, our guest is Matt Sewell, CEO and co-founder at Parallel Systems. Parallel Systems is wholly reimagining how goods can be transported via rail, building automated, battery electric, freight rail vehicles. They look like boxcars that can drive independently and can create on-the-fly connections with one another to team up into mini trains. As Matt describes, their goal is less about upending existing rail freight use cases and more about rethinking what's possible on our existing rail infrastructure to solve use cases that today are in the domain of trucking. Prior to founding Parallel Systems, Matt spent 13 years at SpaceX as an engineering leader in avionics. Parallel Systems has raised around $50 million from investors, including Anthos Capital and Congruent Capital. We start today's conversation with a 101 primer on railways, as we really haven't talked about it on the show much at all. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs. And welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Matt, welcome to the show.
Cody, great to be here.
Matt, we've done over 500 episodes on MCJ. I've lost count, but I don't think we have yet had an episode about rail and trains. So welcome.
Thank you. And I believe you. I can entirely believe that.
But, you know, like you think about the history of the United States and boy, coal-powered locomotive certainly was a big part of that story. And obviously today, most of that, almost all of that, I assume, is diesel-powered. It's maybe a smaller bit of the story compared to highway transport, but still, I think probably bigger than most of us appreciate. So I'm going to dive in. I want to hear all about the history and how rail works in the U.S. But let's start with your background. You were building rockets and now you're building trains. So maybe share a little bit more about that with us.
Yeah, I am an electrical engineer by background. I studied electrical engineering as an undergrad. I came out to LA to get my grad school in EE. And a lot of people come to LA. I just never left.
It's a pretty good place for those of you who might want to have your opinion about LA, whatever you may think. As a native, I'm not native. I've lived here 20 plus years. It's a good spot.
A lot of people in LA are not actually from LA. Like, that's why I think it's funny about it. And it's because it's grown a lot too, but it's hard to beat the weather. I spent 20 years in aerospace, 13 years were at SpaceX, had a tremendous time and journey helping to build a commercial rocket. And when I zoom out, it's hard to believe how far we took that company. And Elon, as many people know, is about getting people to Mars as insurance policy for humanity. And I started, after 13 years, thinking more and more about how much I actually like living here. Space is super cool, but my life is here. And I'm personally not tremendously excited to go move to Mars. I think Mars will make Antarctica look like a paradise. So I started thinking about what am I going to do personally to make sure we don't need to go use that insurance policy. And started thinking a lot about the intersection of climate and transportation.
Matt, I think you're the third ex-rocket engineer, second one from SpaceX and one from Blue Origin who has said that exact same thing. Like they had an aha of, wait a minute, why don't we focus on the planet on which we live?
Yeah, I mean, don't get me wrong, we should have insurance policies, but just thinking about my own mission, that's where I wanted to go. That's what I wanted to work on. And by accident, I started learning about the rail industry. You were touching on, in the beginning, it's this foundational technology, this basic means of transportation that a lot of people have kind of overlooked and taken for granted, but should not forget that it was born out of the Industrial Revolution and forged nations. It's played a tremendous historical role, and it still provides a tremendous service across the world, both passenger and freight. But a lot of people, myself included, don't really know much about the industry.
I think of 1800s America, and it's the rail and the telegraph. Like, that's what made America kind of what it is, yeah?
Yeah, and it's still relevant to America and the rest of the world. And the reason we got excited about rail is because From the first principle physics of it, it is a fundamentally more energy efficient means of transportation. And I'm going to share with you all the reasons we think that is so relevant, but it is high impact on this mission to decarbonize as well as achieve zero emissions. There's two air quality or two climate issues that are really at stake here, which is decarbonization, but also addressing local air toxicity for quality of life for people who live along major transportation corridors and all the byproducts of diesel combustion that affect air quality locally for them. And so the reason rail is so energy efficient is because it's the physics of steel wheels on rail. So you have very low rolling resistance. But believe it or not, you also have a more aerodynamic platform. Now, no one looks at a freight train and thinks that's aerodynamic, but you think about the comparison to trucks, every semi-truck individually experiences aerodynamic drag. And drag at highway speeds is a lot of energy.
I'm going to make a Captain Obvious sort of observation here, but tires on cars are actually designed to have friction to keep the cars on the road. Like they are designed to be inefficient, I suppose. Yeah?
Yes, you need friction. Otherwise, you'd never be able to accelerate. Rail has some friction, but a lot less. So that's why it's energy efficient. So it's 75% less energy per mile compared to a diesel truck. And the skeptics will often ask, right, if I make a battery-powered truck or a battery-powered car, is it really zero emissions, right? Where does the energy come from? And it's a relevant question because the grid itself is getting cleaner, but it is far from clean. And if you want to actually pull a very big lever on decarbonizing, it means use less energy.
So it's interesting. You're taking the energy efficiency angle. I would have thought you would take kind of the same argument that you would use for public transport, which is just law of large numbers. You're just moving more things with one engine pulling them. But I don't know if that's relevant to the argument as well.
There are some like economies of scale, like it's easier to make a more efficient diesel engine when you're building a very, very big diesel engine. But it comes down to the physics as the first principles approach to why this is relevant. Because you do the physics of freight movement, the work you have to do is related to drag. It's related to rolling resistance. So those things being lower objectively improve your energy efficiency.
What happened in the US that caused the highway system to overtake rail as the primary means of moving goods and services around?
Yeah, I mean, we didn't always have a highway system. And the lack of that highway system is actually what inspired containerized freight. It used to take forever to move stuff by truck across the country when, for various reasons, rail could not fulfill that because you're driving over surface streets. And so they took a container and put on a boat and went from New York to Mobile, Alabama. But the US government realized the strategic importance of a highway system. And so we built a highway system, and that, of course, made trucking possible, which has taken volume from rail many, many years ago. But that is the conversion that happened as a result of that.
And also, I mean, by definition, I think the way the highway system in the US works is it's owned by the government, either by the federal government or by state governments. Rail lines are owned by the railroads themselves, owned by investors. What's the whole setup there? I have no idea.
Yes, it's a very good question. So railroads are vertically integrated in the US. And that means that the railroad owns the right-of-way, the land. They own the track. They own a lot of the rolling stock. They will sometimes lease.
They own the land. So presumably, I would guess that means it's much harder to build new rail lines in the US.
Well, that land or that right-of-way they have is often dramatically wider than the track itself. But you're hitting on the most important asset that they own, which is that right-of-way. How unique is it that they have this real estate that connects major metropolitan areas, nearly every major city together through this network?
And are they typically heavily subsidized by the government in any way, or are they fairly purely private at this point?
They're private. The government will give grants occasionally, but there's a big distinction between rail and trucking. And the people who are very active in this industry know very well that trucking is subsidized by all of us because the wear and tear that trucks place on highway infrastructure is supported by fuel taxes that everyone pays. And those trucks put a disproportionate amount of wear and tear on us. Everyone who buys fuel, he pays taxes on that for maintaining the infrastructure or offsetting the cost of actually operating that.
By the way, super interesting. I got an email a few weeks ago, maybe, from the California DMV asking me if I wanted to be considered to opt into a new trial program they're running where, because of the growth in EVs in California, the fuel taxes are anticipated to drop. And so they're contemplating some system where, I forgot what it was, but they were basically going to start charging some kind of fee to, oh man, now I'm going to mess this part of this segment up. But it was some alternative payment method for using roads in California. I didn't get opted into the trial, so I can't speak to it in detail, but I thought it was fascinating. The DMV is already starting to think about this stuff.
Yeah, as electrification becomes more widely adopted, I think that revenue system has to be revisited. And I think objectively, the fairest way to assess it is based on weight, but probably the easier way to look at weight is through axle count. And if you look at private toll roads, like that's how they charge tolls, is based on how many axles you have.
So we've kind of described this system of rail, and you were talking about how it's more efficient to move goods and services around. We've talked about how the setup is a bit different from the highway system, where the public essentially own the highways. Explain from an emissions perspective what the rail networks look like today with these heavily diesel-powered engines. Is it a heavily emittive system today?
Yeah, it's a great question. So just in terms of like calibrating where the state of technology is in rail today. So the industry today use diesel electric locomotives. And what this is basically a diesel power plant on a steel sled. So they generate electricity with this diesel engine, and this is part of the energy efficiency. This is part of transiting that power efficiently to the wheels. And the electricity then powers motors and the wheel sets below the locomotive. But these locomotives are massive. They will do about 100 megawatt hours of work when they're fully fueled with diesel.
So just to make sure I understand, Matt, so it's not just purely an engine creating pistons that are driving a front drivetrain forward. You're actually sending power to the entire set of wheels electrically. Am I following that correctly?
So you have the locomotive, which will have 6 axles, 6 axles on it. And the diesel engine on board the locomotive is powering a generator, and it's making electricity. And the electricity is routed to the wheel sets by electrical conductors, and then they power motors below that. And so this allows them to run this engine basically at a very narrow operating range that helps with the efficiency they were asking about before. And then they can control the motors to apply the right torque or speed depending on the conditions.
So much more efficient than an engine that was purely just pulling an entire train with a fossil fuel powered drivetrain. I don't know if I'm even saying this correctly, but
yeah, I mean, sometimes like the axle, like the amount of torque and power transmitted, like sometimes it is easier to transmit the power over wires than it is like with an axle. So I want to run some numbers by you just to like calibrate on why rail is so relevant here. So even though rail is still using diesel, because it's so energy efficient, I want to go back to trucks. If you look at an electric truck, that truck has to overcome the same rolling resistance, the same aerodynamics, more or less, than trucks do today. So even though you've made that truck electric, it's still very work intensive. And if you go back to how much CO2 does the grid indirectly generate to recharge that battery, I think the analysis that's very surprising to a lot of people, but is why Parallel is on this mission, is that the indirect CO2 generated to recharge an electric truck's battery, this is a Class 8 electric semi-truck, is more CO2 per mile than a diesel electric locomotive generates burning diesel.
that's what the current state of the U.S. grid being 60% fossil fuel based, yeah?
Yes. So we should still pursue electrification of everything, but we want to make a big impact. The biggest impact is get more things to rail. So diesel locomotives do burn diesel that is less CO2 than trucks make, but you still have local air toxicity of any diesel combustion product. And so that's a highly relevant topic here in California. CARB, South Coast, AQMD, very, very interested in reducing any diesel combustion process in this area to help further with air quality. But the most impactful thing you can do in terms of freight transportation right now is try to move more things to rail.
What's holding it back?
So the challenge with rail is that through the legacy of this industry, the architectures that have evolved, freight rail does one type of service generally pretty well, which is moving lots and lots of heavy things long, long distances. And then all the other permutations of distance and how much volume is moving between these freight lanes that exist in any country, those generally go to trucking. And that's why you see the trucking industry is 10 times the size of the rail industry in the US, is the flexibility of trucks gives them a very, very large addressable market. They can be faster, they can have higher service quality, and they can be cheaper door to door in the right configurations. But rail, as an example, like rail dominates freight lanes like LA to Chicago, where you have lots and lots of freight.
Why doesn't rail dominate shorter routine trips? In particular, I'm thinking drayage trips from ports to warehouse fulfillment facilities, et cetera.
It's a great question. And there are people pushing to make that work, but it's hard to work because rail has a lot of fixed costs associated with it. You have those big locomotives, you have a crew, and you need to amortize those fixed costs over lots and lots of freight. And so we're dealing with these short moves, you need a place to park a train that big. And there are a lot of initiatives. We see this a lot in Georgia, outside the port of Savannah, is they have strategically set up many inland ports that are served by rail so that you're alleviating highway infrastructure from that truck congestion. And then trucks will go to that inland port and pick up that container. But it's a very, very big capital commitment to operate at the right scale for rail to do that. And often what is a problem for that service design is that that big train has a very, very finite place to go, and it has to be a very expensive place to go because it has to be massive to accommodate the scale. And now you need to put it on a truck to go that figuratively first or last mile, which they call drayage. But even going from like LA to Phoenix or San Diego is considered drayage. And drayage can be very expensive because the truck, the driver are far less productive than if they're just like traveling the open road. And so drayage can strangle rail's ability to serve some of these markets because at the end of the day, that shipper is looking at what is my door-to-door cost and how consistently can I get that freight? And that's where rail starts to break down, is that even though the rail component might be relatively cheap, when you add the truck drayage components to it, your door-to-door cost can be more expensive.
So I'm hearing one requirement is, to some extent, distance matters in order to justify the need to have a long train. And you also said that pulling something with a lot of weight also presumably matters a lot. What are some of the industries that still primarily do rail transport, given that?
Yeah, the industry itself in the US, I'd say is 25% intermodal. So intermodal is like these steel boxes that come off container ships, or even putting trailers, like UPS Ground and FedEx Ground actually quietly do a lot of their services. They'll pick up a trailer and put it on the back of a flat car, and then they haul across the country as fast as they can. But 75% of the rail industry revenue is from bulk transportation. So this is historic commodities like coal, which is on the decline, but other sorts of like chemicals, like industrial products that a lot of people probably don't spend a lot of time thinking about. Grain, too. Grain is exceptionally heavy. You load a hopper car full of corn, that could weigh 100 plus tons, way, way more than what a truck could carry. But this is why rail is like a major backbone of freight transportation in this country and worldwide, is because it moves so many of these important commodities that people don't always appreciate are moving around.
It strikes me, too, that when I think of companies that are pushing the envelope in supply chain and logistics today, like Walmart and Amazon, the types of goods that they're moving are less likely to need this rail infrastructure, it sounds like.
Yeah, it's because they're in this era of same day or overnight shipping, this fulfillment, right? Service quality matters, speed matters a lot. And those types of transportation needs are premium services. Like intermodal is generally a premium service because it has to move fast. The coal's been on the ground for a million years. It doesn't matter if it takes 2 extra days, right, to get to where it's going. Where there are goods, there's inventory tied up inside that box. And the more quickly, the more consistently we can move it, the more value is created. And those industries, e-commerce fulfillment, are really driving a lot of that shift. And that's something that the rail industry has to be better prepared to answer, because where they're really good is something that's on the decline. And where there's growth opportunity for them is where they really need to improve speed and service quality. And that's not what rail is good at right now in its current form.
So do you see the opportunity therein being in adapting rail to solve these sort of, I would almost call them non-critical use cases, which are essentially lifestyle luxury use cases relative to heavy industrial commodity use cases where time doesn't matter as much as just getting to the absolute lowest cost possible source of transport?
Yeah, it depends on what it is. Like grain and ag products are definitely time sensitive, or rocks out of the ground. Like there's no hurry needed. It's just like get as cheap as possible. But that's what's happening. That's the transformation happening. And the rail industry is at a point where they've been very, very successful financially for decades because they've really gotten it down in terms of how to operate their service. They've gotten the cost down, highly, highly profitable for those operations compared to trucking, which live on razor thin margins. The challenge, though, is that they've even shed business to get this really low, what they call an operating ratio. And so the lower the operating ratio is, the higher their profit margins are for those operations. There's a lot of consensus, though, that those ORs are not really going to get any lower, not realistically, not without making major, major trade-offs. And so where they are is they can't keep growing profits by reducing their costs. They have to grow top-line revenue. And so meanwhile, you have, again, the legacy commodities like coal on the decline, intermodal volumes are down, yet intermodal trucking is where they should be growing. They need to grow. They recognize that. But their dilemma is they've already picked all the low-hanging fruit. And so that's where Parallel comes in, is that we are offering an alternative tool to use on that existing infrastructure that allows them flexibility, higher service quality, that gives them the means to compete over some of these freight lanes with ways that they couldn't in the past. And so we're arming them to steal volume from trucking and move it to rail, where we can move it in a very energy efficient way and realize true CO2 reduction.
Hey everyone, I'm Yin, a partner at MCJ Collective, here to take a quick minute to tell you about our MCJ membership community, which was born out of a collective thirst for peer-to-peer learning and doing that goes beyond just listening to the podcast. We started in 2019 and have grown to thousands of members globally. Each week, we're inspired by people who join with different backgrounds and points of view. What we all share is a deep curiosity to learn and a bias to action around ways to accelerate solutions to climate change. Some awesome initiatives have come out of the community. A number of founding teams have met, several nonprofits have been established, and a bunch of hiring has been done. Many early-stage investments have been made, as well as ongoing events and programming, like monthly Women in Climate meetups, idea jam sessions for early-stage founders, climate book club, art workshops, and more. Whether you've been in the climate space for a while or just embarking on your journey, having a community to support you is important. If you want to learn more, head over to mcjcollective.com and click on the Members tab at the top. Thanks, and enjoy the rest of the show.
Why don't you describe Parallel for us?
So Parallel is developing really any of the technologies for rail to tap further into this infrastructure, this amazing infrastructure that they have. But the problem is you have these barriers for the markets that rail can currently serve, and that's what Parallel is working to resolve. So we are developing a battery electric autonomous vehicle. It doesn't require a locomotive. We work together in platoons, but every vehicle is self-contained and has the powertrain, the batteries, the compute, radios, sensors to move freight around the network. But what's unique about our platform is not only is there no locomotive, but there's no coupler. And part of our technology stack for this is also the software that enables all this, not just the software to control it, but the software to integrate into a railroad alongside their traditional operations. We're not telling railroads, get rid of your legacy freight trains. We're giving railroads a set of tools to work alongside those trains that allow them to convert more freight activity to rail.
And so, like, when I've seen some of the video on your website and other things, just to give my impression, basically, you look like individual boxcars that kind of move on their own and then can attach and detach with other cars in the line, such that you can essentially change how long the train is based on needs, which in that regard, does that mean a shipper would sort of own the load for one individual car And then do they have any skin in the game on what other cars are part of the train that they create or not? Or I am definitely not speaking your lingo, I know, but maybe help us understand what the kind of relationship is from one car to the other.
Yeah. Let me help you out. So I want to work on your analogy you're making there in terms of explaining is think of it as a self-assembling train and imagining what you can do with a train that self-assembles. And for anyone who has spent time around trains, it is incredibly labor intensive as well as capital intensive to build and sort trains. And that's where a lot of the opportunity is, because a lot of rolling stock spends a lot of time not moving, because even if you loaded that one rail car, that rail car is held hostage by all the other rail cars that need to get loaded before you have a train that's big enough. And that's why you will see box cars, different types of rolling stock with graffiti on it, because it spends so much time sitting around inviting people to just use it as a painting.
It's like if your flight from LA to New York sat on the runway until every single confirmed passenger was actually there, I guess would be the analogy, yeah?
Yeah. Yeah. Or imagine you're going to have all the planes leave at once everyone is on board, right? So you're just going to sit on the runway for hours and hours. So what is unique about Parallel is that we're able to accomplish truck competitive economics without large scale. We can do it with small scale. But a lot of the opportunity is also about being able to sort this freight on the go. The analogy I like to use is it's like a routing packets in a network, but very importantly is no one needs to be there, because today rail cars are coupled together through what they call Genie couplers. These are couplers that are invented in the 1800s, and they still to this day require someone to be right there to pull a pin to separate it. And then you have airlines for the brakes that need to be manually connected together. So one of the very labor-intensive things is that someone needs to be in that rail yard supporting these operations of breaking apart and hooking up rail cars. And not only does that take time, it also is dangerous. It's the most dangerous part of the job for any railroad employee. It's not being on the main line. It's being in that rail yard where your attention is required in a lot of different places. And you have these very heavy cars that are maybe getting shoved by locomotives that are not immediately in your area, so you can't hear them. And so that's another layer of what Parallel is doing, is not only are we dramatically improving the operational efficiency of sorting this freight, building these trains, dropping stuff off, is we're taking people out of direct harm's way. And so there's still people involved in overseeing these fleets, loading freight, working with customers, but they're not directly on those trains the way they are today.
And you talked about one of the big requirements for rail relative to trucking was right now, just from a cost perspective, needing to mostly be these monolithic long haul routes. I assume with the Parallel system, you anticipate you're somewhat breaking up that need.
Yeah, we aren't proposing to move single containers over the network because that's not aerodynamic, and it's also not the best use of the network capacity, but we can move in much, much smaller, what we call platoons, these self-assembled trains. And it is a very powerful capability that allows us to drive freight further into the capillaries of the rail system and get it closer to shippers and customers. And we talk to a lot of shippers or customers who do want their facility to basically become the access point, and then you're never putting on a truck for that last mile. And that's a really transformational change for this industry.
Now, there's no locomotive involved, which I was calling the engine earlier. So no engine pulling this thing. Was it wholly battery powered on a per car basis?
Yeah, we are a battery electric powertrain. And besides the energy efficiency that we're talking about before, and let me put some numbers on that too, because I think there's really three big advantages for battery electrification in rail as opposed to Class 8 trucks. And so one is, that, of course, the energy efficiency. So a 500-mile range electric truck is going to need a megawatt-hour battery. For a rail, our application, we only need a 250 kilowatt-hour battery to have that same 500 miles of range. It's like breakthrough headline the next day is like energy density at 4x, same price. Like that's basically what we're doing here. The other advantage of deploying this to rail is that you have a lot of weight capacity in the rail system.
Let me come back to your first point. Whereas a truck is certainly going to stop sometime between mile 0 and mile 500 because the driver has to get some food or use the bathroom. A rail car, in theory, doesn't, right? It just keeps going. But you are going to have to make charge point stops along the way, unlike a typical train today. Is that correct?
Yeah, I mean, it's where we fit into rail too, because the rule of thumb is you don't put intermodal volume on rail unless you're going to use 500 miles. There's a few exceptions to this, but that rule has generally been proven over and over again. And the range of our platform is about 500 miles. That doesn't mean we're limited to routes that are only 500 miles. It's a matter of how often we're going to stop and recharge, but that's why it's going to be not anything happens anytime soon that we're going to Chicago with this from LA. But what you touched on is actually one of the advantages of this is that rail's generally disadvantage with trucking is that it's on a captive network. I can't go to everyone's back door to drop stuff off. But when I invest in my charging infrastructure, number one, it's less CapEx because it's a smaller charger, 250 kilowatt hours versus a megawatt hour. If I want to charge in an hour or two, right, you can do the math. It's a quarter the size because you're paying by the watt for chargers. But then in terms of the economics of it, you care about the utilization of it. And being captured to that rail network, it means that you can have a very predictable service where you know how often you're going to be using that charging infrastructure. So we think it really makes for a compelling economics, smaller upfront investment, but then more predictable payback on that investment.
I mean, each one of these cars presumably is significantly more expensive than a typical rail car, but you're not having to own the locomotive/engine, I suppose, but you also have to install charging infrastructure. So there's certainly economics trade-offs. You're hoping or assuming that the efficiency of getting more multimodal transport out of this ultimately drives payback, yeah?
Yeah, there's no question that what we're building is going to be more expensive than a rail car. It's hard for anything to be cheaper than a rail car. But that's not economics. So the economics is about how much revenue are you going to get over a certain amount of time with that. And because we're not gated by availability of a locomotive, we're not gated by availability of crew, we can have a very, very high level of utilization with this platform. And so we get a lot of questions about how does the economics parallel compared to traditional rail. We don't think that's the right comparison. We think the right comparison is against trucking economics because that's what we are working to take volume from. And so one of the coarsest measures to do that comparison is like, what's the total cost of ownership over like certain time and usage?
So it's not, hey, agricultural company, compare getting your grain from Los Angeles to Chicago on traditional versus this. It's, hey, railroad company, compare the different use cases and problems you can now solve if you had this system on your line. You could continue your current business and you can add new business opportunities to your platform.
Railroads are our customer. And so what we spend a lot of time talking about is this is a growth engine for you. This is a tool that allows you to do things you can't really do today. That's a really important clarification for how railroads think about how to use this, how to wield this. It's like it's not a train. It's not a train in the conventional sense. But a truck, a diesel truck, 10 years, 1 million miles of life is going to cost, between the truck and the fuel and the maintenance and the driver, is going to cost you roughly $2+ million to own and operate that truck. The platform we're developing is going to be about half that total cost of ownership.
Are there any railroad companies today who have expanded into trucking already? Like who are seeing both of these sort of business models in real time and can compare them?
Because they are so focused on their operating ratios, they're very reluctant to become a trucking company because it has very, very high operating ratios. So it would, right or not, is they don't want to get into the business because it does not make their financial metrics look attractive.
To that end, then, are you getting pushback from any of them who just frankly don't see themselves as growth companies? Like they want to be consistent, they want to maintain the business they have?
No, quite the opposite. A lot of excitement in seeing us do the pilot we're pursuing in Georgia outside the port of Savannah. And we're also active in Australia right now. So there are a lot of people who have given themselves a front row seat to see how this happens, but certainly no pushback. They, of course, are going to ask the hard questions like making sure the numbers work, but zero question of like whether or not this addresses a real problem that they have.
Tell me more about some of the pilots.
So we are very excited to be working with Genesee, Wyoming, and we anticipate starting a pilot on 2 of their railroads in southern Georgia, outside the port of Savannah. And this pilot is about verifying our operating practices in a real-world setting. And one of those is showing that we safely can coexist with traditional freight rail operations. And we hope to start that by the end of this year. And it's a multi-phase pilot, and it starts with baby steps, and then we graduate into operating over wider and wider sections of that network. And ultimately, we'll be able to work with a select number of shippers who have expressed interest in perhaps moving some of their freight on that service. And then we have actually a vehicle in Australia right now too. So one of our partners is very excited about what this can mean for their network. And we are working through some mainline track testing opportunities with them that we think will happen in the next 12 months.
On the Georgia pilot, what are some of the safety issues that you need to try to understand?
So one of the most important things is that we are going to be compatible with the rules of the rail. So a lot of, even though this is a very unique technology, is we always go back to making sure that we are grounded in those rules today. We can't have different rules. We have to use our technology, our operating practices to be compatible with them. The railroads are regulated by the Federal Railroad Administration, and there's many regulations that have been learned over the course of time about best practices for a safe rail. And so we've gone through those regulations, and we have filed an application with them regarding which rules we think are relevant to what we're doing. But we're always very, very aware of those practices as we consider how to roll this technology out. But we also develop a database of all the things that we see as risks, and we work closely with our partners and regulators to talk about how we mitigate these risks, how we verify that the controls actually work. So the safety case, making the safety case, operating it safely is incredibly, incredibly important to us.
When you're testing, how much of it is testing a single train kind of going back and forth on a route or a single car? And how much of it is this coupling, decoupling, sort of creating platoons on the fly, sort of the bigger vision that you talked about?
It really depends on what we are evaluating, to answer your question. If we're testing a brake system component, for example, we only need a single car to be testing that. And we have access to some test rail here in California that gives us a test environment to do that. But if we're testing dynamics between platoons, we have 3 vehicles out here in California, so we will test platooning. But when you're going through this process, you have a definition of the system, subsystems, hardware, et cetera. And what engineers are doing is systematically going through those. What are the requirements? How do we know we're actually meeting these requirements? So when you're doing testing, it's usually with intent to test or create test data that can be used in analysis to address, okay, this is a requirement. Are we actually meeting or exceeding it? Also validating, is it the right requirement? Does it work correctly? So it really depends on like what part of that narrative about this is our technology, this is how it works, that we're working to understand and prove it out. But there's a lot of testing to look at all the different subsystems and make sure they're working correctly.
And how did Australia come about for you guys? That's not close to where you're building these trains today in Los Angeles.
It is not. And I joked about it, and then I found out I was actually not off. We're doing a pilot in Savannah. I said, wait a minute, it's like Perth is on the other side of the earth. And I was like, wait a minute. And I brought up one of those websites, right? And sure enough, the Indian Ocean off the coast of Perth is what's on the other side of the earth from Savannah. So it's like we couldn't get much further apart. But I mean, there's ARC infrastructures who we're working with there, tremendous, very, very enthusiastic about this, have been great partners. What's unique about Perth, though, is that they are planning a new container port, and they have had the foresight of wanting to avoid the truck congestion issues that typically go along with successful ports. They want to really set a bold vision for a lot of this container volume going by rail. And you have, of course, a lot of challenges with legacy rail actually stepping into that role. And we were introduced to each other by someone in our mutual network and just clicked and made a lot of sense for where Perth wanted to go with this container port, but then all these other opportunities we've seen emerge since then. We're very excited to be working with them.
How do you see other geographies playing out for you? When I think of rail, I think of obviously Europe has an extensive rail network. China, I believe, has a fairly extensive rail network compared to at least highway network. What do you see the future looking like in that regard?
There are many, many countries that have applicability to our technology. As a startup, though, I think what is really important is to stay focused on a few things rather than just go after everything at once and then get nothing done. So we've had a lot of interest in Europe. We have some great relationships with people over there that we hope to be formally working with someday. But you spotted it, like a lot of relevance to some of the challenges there. And Europe has also been a leader in terms of identifying a policy of like, we should move more things by rail because it's energy efficient. It's like Parallel didn't discover this. It's like we were just agreeing with what many others have pointed out. But the challenge is like, okay, move more things to rail, but how? Because you can't lose sight of the economics too. And that's one of the unique challenges of what we're doing is we're not just thinking about the technologies, we're thinking about being successful in the context of what matters to shippers, which is ultimately price and how consistent and fast is the service.
And we haven't really hit on your business model. Are you selling trains to people? Like, what does the actual company look like?
Our model is to sell vehicles to railroads. It may be to a third party to offer a capital lease back to a railroad. We have services that we support while that asset is owned because we have a very extensive software stack. It's not just the perception software, it's also train control integration, enterprise integration, user interfaces. There may be a point in the future where we lease this out. We don't think that's the right step for us as a startup right now. But I could certainly see a future state of Parallel where we have a asset pool either owned by us or owned by someone else that's leased out to whoever has the need for a service enabled by Parallel's vehicles.
Well, it strikes me, Matt, you hear people say all the time, climate change is a systems problem. We have to redefine our systems to solve it. And what I'm hearing from you is a bottoms-up rethinking of how freight moves around. It's not easy, right? Like you are innovating on multiple incredibly challenging vectors at once, from technology to inertia of existing systems to how these systems are financed to the business models of the companies moving things through them. And I'm sure there's a ton of other factors on top of that, from regulatory to labor to whatever. How did you wake up and decide, yeah, let's go do this? Because this is a big undertaking. This is not an easy problem.
Yeah, I think the honest answer is I thrive on hard things. And so it's not just the technology, as you pointed out. It's like, it's making the safety case, it's overcoming inertia with an industry that has not changed a whole lot. It's such a big impact. It's such a big enabler that like you have to do those things. Like you have to try this.
Where do you need to be focused for the next year? Like, of all of these things that you need to solve, what is burning down the house right now for you to get an answer on?
Our focus this next year is going to Georgia, being in Georgia, doing this pilot, and being on mainline track in Australia. Those are the top two important things for us.
And how have you financed the company so far? Presumably you've got a group of committed investors willing to take on a significant amount of risk when you first showed up and said, hey, I've got this idea.
Yeah, we did a seed round in 2020 led by Congruent, and we did a Series A back in 2021 led by Anthos. And we've been really excited to be working with Congruent, Anthos, as well as Riot and Embark, and most recently 8090 Industries, who's joined us as an investor. But we're always fundraising.
I assume there's a component to your business where you're going to have to raise some debt to manage manufacturing in the future when you're getting to the point of starting to sell these at higher volumes, yeah?
Yeah, as we look at the capital plans for the company, absolutely, I think that's in the future where we will have some debt probably to build more and more vehicles each year.
Matt, what have we not hit on that we should make sure to cover?
I think we've hit all of it. I think just to reiterate, what Parallel is doing is enabling modal conversion. We want to take volume from trucking and move it to rail because of the climate benefits, but also, as many people can appreciate, is alleviating the burden of truck congestion from highway infrastructure. It makes for safer roadways, easier to navigate roadways.
I've got a follow-up based on that description, which is, it sounds like the idea of what you called sort of traditional freight transport, which is these heavy goods over long distances, can still coexist with you. It might in the future shift from a diesel electric powered locomotive to a hydrogen electric powered one or a wholly battery electric powered one. And that process can still be efficient for the lowest cost, longest distance, monolithic transport that still has to happen across a large country like the United States, and that your system can work in parallel with that, to use a loaded term, being that your company has parallel systems, to find smaller, more micro routes along those same rail lines. Am I thinking correctly about how you might see the future?
Yeah, there could very well be an evolution in locomotives as they are today, which will likely have a lot of support because of the assets that have already been invested in all the rail cars that are out there. But what parallel does is help open lanes that would be out of reach for that type of train. We become a more cost-efficient feeder system into those traditional intermodal routes. But what we're doing is helping the rail industry break down these barriers that limit their adjustable freight markets today.
So you don't have to necessarily believe that you're going to completely replace the way the entire rail system works today. You just have to believe that that system may continue to get more efficient on its own, but the existing infrastructure that's already a sunk cost in this country can be extended upon to be used for different use cases if you change the form factor of what travels along it.
Yeah. If you look at a highway system, you have many, many different modes of transportation that use that infrastructure. You have motorcycles all the way up to semi-trucks. And we think rail doesn't need to be necessarily limited to the semi-truck model, or maybe like a bus analogy. It's like we can have Ubers or taxis that can share that infrastructure too.
Matt, really appreciate you taking the time to join us, share more about what you're building, and can't wait to continue to follow your progress.
Thank you, Cody.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at mcjpod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ venture funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.